So for this homework assignment, I will start off by inputting all the numbers that were given here into Google Collaboratory. And before doing that, I will import numpy as np. And then we have a equal to 1 over 6, 1/6. B is 9 over 16, C is 8 over 27, D is 2, C1 is 0.6, C2 is 0.387, and C3 is 0.559. And then I will have to randomly choose 50 pairs of Reynolds and Prandtl numbers. To do that, I will use np.random.randomState. And the reason why I'm using random state because this method uses the same parameters that will always produce the same result up to round of error. So n equal to 50 because we use 50 pairs, and Reynolds number. So in the question it said Reynolds numbers logarithmically spaced equally from 10 to the -4 to 10 to the 10th. So to do that, I will have to use a function called log space. And the starting point is -4, ending point is 10. So as you can see here, log space will return numbers spaced evenly on a log scale. And the size is n because we need 50 pairs. And then Prandtl number, I would do the same thing. Log space will go from -1 to 4. Alright, the next thing I would do is to calculate the Nusselt number using the equation and parameters above. So I will just basically transfer this whole formula into Google Collaboratory. So Nusselt number would be equal to and then we will have to generate synthetic data by multiplying each of the 50 calculated Nusselt numbers by a normally distributed random number with an average of 1 and standard deviation of 0.02 to simulate a constant relative error of 2% in the collected data. So to do that, I will have to call another variable as new Nusselt number data equal to the calculated value times np.random.normal. Mean is 1, standard deviation is 0.02, and size is n, which is 50. Finally, we will have to fit the synthetic data to the model above by minimizing the mean relative square error between the model and the synthetic data. So there are two things that we need to worry about right here. First, minimizing, and second is the mean relative square error. So first, I will have to import minimize from scipy.optimize. And then I will define a new function called mean weighted square error. This is a function of v. V is an array that includes the value of a, b, c, d, c1, c2, c3. Nusselt model, I would use the same formula to calculate the value of Nusselt model, so I'm just going to copy and paste here to save time. And then this function will return np.mean of Nusselt number model minus data divided by data squared. It's just how we calculated mean weighted squared error. Then the result would be minimize the mean weighted square error with the initial guess of A, B, C, D, C1, C2, C3. And finally, we will need to determine the corresponding coefficients, which we already calculated. So the coefficient that we need to find was result.x, which is this.